Hello everyone, my name is Vipul Sonil Patil from IIT Gandhinagar. Welcome to CSE 329 Foundation of AI Project Showcase. In this video, I will be presenting an interface Sudoku solver that demonstrates various interface heuristics. This project is built using React HTML, CSS and JavaScript and have hosted on GitHub for easy access. We will be exploring how these heuristics help improving problem solving efficiently, particularly in constraint satisfaction problems like Sudoku. Interface heuristic plays a crucial role in AI by allowing us to make educated guesses and narrow down possibilities, significantly reducing the complexity of finding a solution. In the context of Sudoku, this means we can quickly identify valid number for an empty cell and systematically solve the puzzle. Let's take a quick look at Sudoku Solver and some of its features. This overview will help you get familiarized with the implementation before we get into the code. On the screen, you will see a Sudoku board where you can interact directly. If you hover over an empty cell, possible valid numbers of that spot will pop up. A simple click will let you add or remove a number. You can also have a drop down menu with options like valid domain, backtracking, forward checking, or consistency. These options let you explore how the possible number changes based on the method you select, helping you understand what numbers can fit in each cell. Plus, you can pick any number from the bottom selector to check its probability of being valid across all potential grids. You will also see the probability shifts as we fill more cells. Finally, to really see how the everything works, click on the visualize button. After choosing a method, you will be able to watch step by step how the puzzle solver tackles the Sudoku puzzle, making it easy to understand the mechanism behind each approach. Also, you will have a option to add your board by clicking on set board option and inputting the values you need. So next, coming to the our code section, there are four main components in our code section. First is the board, which is responsible for sharing the board to the main display board. This is the display board. This is responsible for showing the board on the screen. Next is the num selector, the bottom on the screen, which the bottom selector 1 to 9, that is shown by this particular thing. Then display parameter, so this is responsible for the parameters which we are giving to the code, basically the speed parameter or the whether it be selecting which method we are been using. So these are for the front end part, and the main which is solving the Sudoku board is in the Sudoku solver. So here are some states management done. Next is the board select. This method only call the board from the boards and basically import the board and share it with the display board section. This is handle the change whether you are inputting particular number to the board and that is being set to the display board, like here set, and basically based on this update possible values which is responsible for the first method. Then the forward checking and the R consistency are all updated after as you add a new number. So coming to the first update possible values, so the major thing, the hover matrix is the important thing which is responsible for whole process of every, like for the backtracking also, for forward checking also, and for R consistency also. So here the you can see that is valid is called. So is valid is nothing but a function that checks whether a particular number is valid on that particular cell, like it checks in that particular grid. So I will show. So it particularly checks in that row, then check in that column, and then checks in that particular grid. Next is the forward checking. Forward checking is the is like that it also it also counts for the row, column, and the particular grid, but it also counts like if a particular number is only once. So if a particular number is only once, then possible values of a particular grid is only one. So it assumes that if that on the number that is shown on that particular cell is one, so it will be coming there. So that number will be also removed. So this function works like that. It checks if the possible one value is 1, and removes the if the number is that number is coming to the other cells in that particular row or column or that particular grid. So basically it works like that, and this is the function which is been called. And from here the board section, like the same, the if we were using in is valid, now we are using check forward checking. So basically responsible for removing that particular number or that particular cell. Next is the arc consistency method. Arc consistency is the forward approach of the forward checking. So what it does is the same like the what forward checking does, but at the furthest level it also check again and again. Like in forward checking, what is happen is like there is only one arc from a particular set, but in arc consistency there should be a multiple arc. Like there should be arc connecting to from each cell to other each cell. So breadth first search method. So this is been called from here the breadth first search. Yeah. Uh-huh. So this is been called this only. I did this because of well, it would be helping, but what happened is for the sum like for forward checking and app consistency, the state management was not done properly. So I take from the helper and put it back in the Sudoku solver. So this is not but a basic breadth first search approach to solve the board, which is not that means it makes a graph. It makes a tree like structure from every bp from every the state of the uh, Sudoku board, and from that every state it goes to the next state, and when the full Sudoku board is been completed and is been valid, so it's just throw that particular board. Yeah, this is only. And see, this is the these are the main function, but not that main because they are being called, but they use this so solve Sudoku tracking like our previous boards, previous hover matrices to show. Similarly, this board also takes the help of hover matrix. So basically the main thing is done by the hover matrix only. These are only the calling type methods, and how to reduce that time like thing. Here also, so are in arc consistency we take help of arc consistency hoverboard. Yeah, now this comes to the probability. Now the when we call the like what is the probability of a number. So it's what do is basically take that grade and distribute over the board like thing, and count the probability for that particular board, then row and then column like things for the only the function that are been dotted, not for the all. And this is for the just for weighted like probability. So like which are the main and where are the main probability should go. And these are same that neighbor coordinate weighted giving for weighting. And this is the main function which calls, and then the previous function is being called that calculate probability, because this function hovers through whole grid. Like this is the possible matrix, probability matrix for each grid, and for this is being called. So basically for each particular cell it is being called calculate probability, which is the above function. These are the same drop down function which like which are being selected from here and given to display parameters like things. So yeah, this was the main code overview. As we discussed earlier, we can see valid domain of a blank cell on hover, and on a click we can add or remove a number. We have also seen how we can visualize step by step how each mechanism tackles the Sudoku by pressing the visualize button. Now let's dive deeper into how the method selector impacts the board in real time. I will be first selecting backtracking algorithm. As you can see on the board, when we select the backtracking, the domain for the current hover cell will show the possible numbers. Let's say for this particular cell, the domain shows 1, 2, 5 and 6, and for this cell it is 2 and 6. Now going ahead and adding a 6 here. Notice how the domain instantly updates. Initially, the domain for this cell was 2 and 6, but after placing 6, it just reduced to 2. This is how the hovering mechanism works. As we fill the numbers, it narrows down the possible choices for the other cells depending upon the method selected. You can see the other methods too, like how domain for the blank cell is getting changed for each new input. This behavior is also visible in probability matrix. When we select any number, for example 6, from the bottom numbers and add a 6 here, it affected across the entire board. The probability of 6 being valid in the other cell decreased. This shows how our metrics update the solution in real time, narrowing down the possibilities not just locally but also across the board. And up till this point, we have seen how adding or removing a number affect the board based on the selected method. Now let's take a closer look at how the hover matrix, which shows the possible values for the cell, changes depending upon the method selected. Let's start by selecting the backtracking mechanism. One limitation of backtracking method is that it does not catch the issue that might arise in future. For example, as we are using backtracking here, you can see the hover matrix of this cell shows only one possible number 2, and for this cell it is 1, 2, 5, 8 according to the current state of the puzzle. However, when we switch to the forward checking mechanism, the algorithm takes further constraint in account. In this case, even though 2 appears to be valid in the backtracking approach, the forward checking reveals a potential conflict. When we hover over the same cell, you will see the domain has changed. Originally, the hover matrix showed 1, 2, 5, 8, but with forward checking mechanism, 2 is no longer a part of domain. This is because adding to this cell would cause a domain of this cell to be blank, which is a sign of incorrectness. Forward checking catches this further flow and removes 2 from the possible choices of this cell, leaving only 1, 5 and 8 as valid options. So, by switching from backtracking to forward checking, we can see how the hover matrix for this cell has changed from 1258 to just 158, showing that 2 is no longer a valid option. This demonstration of how forward checking anticipates conflict that backtracking cannot offers a more proactive way and avoid error in solving the puzzle. You can see this update reflected on the board as also in the probability matrix. When if we are originally looking at backtracking algorithm, the probability of number 2 being valid in a specific cell might have been higher, but as soon as we shift to forward checking, you can see the probability matrix updates to reflect the reduced chance of the number 2 get fitting into that cell. This is how forward checking helps in narrowing down the possibilities in real time. Lastly, you can experiment with this algorithm and see changes yourselves by clicking on the link in the description. Whether you are working with backtracking, forward checking, or exploring the probability matrix, this tool will give you a clear visual understanding of how this algorithm works behind the scene to solve the puzzle. Thank you.